Wireless local area network vocabulary and topologies. Having the right terms and understanding what they mean as we look at and organize our wireless networks is really critical, and that's why I'm super excited about sharing this video with you. Let's begin. I'd like you to imagine that you and I are going to join a club. So we go to the very first meeting, and you know what we're going to experience? We are going to experience some jargon, some vocabulary that we're not used to. And there might be terms and words, and we might just say, oh, we'll find out what that means later. And after a while of being exposed to the people in this club, then we can better understand those terms. Well, I've learned that vocabulary, the actual words that are used and acronyms that are used, are sometimes a huge stumbling block to people picking up a new technology. So in this video, we're going to focus on some basic concepts as far as terminology and some network topologies we're very likely going to run into as we set up, manage, and troubleshoot wireless networks. Every time a new term or acronym or word comes up, we'll go ahead and describe together exactly what that is, and we'll link that or anchor that to a graphical representation of it as well to help make sure it sinks in and that vocabulary becomes almost second nature to you. When I come across a really cool idea or something that really helps me, I love sharing that. And what I want to do is share with you a tip that I use all the time that really helps me learn a new technology, and that is to write it down. So even if you never go back to those notes, the fact of writing it down as we're going through it together will assist you in helping make this vocabulary and these terms yours. So let's begin with our first concept, and that is ad hoc mode. So if you've got your pen or pencil, I would strongly encourage you to write that down. Now, what is ad hoc all about? Well, it's a Latin phrase, and it represents a solution designed for a specific problem or task. That's the general idea of ad hoc. Let's take a look at a typical problem that three users, let's say you, me, and one other person might have. Let's say we're taking a road trip. We're in the middle of nowhere. We've got our laptops out, and we need to share some files. And we didn't bring any flash drives, and we didn't bring any media like CD-ROMs that are burnable. How could we share that information? Well, what we could do is we could organize our own wireless network on the fly right there in the car if each of our laptops had a wireless adapter. So one of us would take our laptops and we would define the parameters for the network. We'd give it a group name. We'd specify what radio frequency we wanted to go ahead and use for this ad hoc network on the fly. And then the other devices would go ahead and somebody join that network. And we could all communicate together on this ad hoc network. So what is ad hoc mode all about? Ad hoc is just devices, independent devices on their own power, building up a network without any infrastructure whatsoever. So if you like, one way that we can remember our analogy is that we're all in a car. Let's say we're in a Honda. You, me, and another person, we're all in a Honda that is A and H, ad hoc. And we're just building a wireless network on the fly using the wireless adapters that are built into our computers for sending and receiving data back and forth. Now, in our network, we need to make sure that each of our laptops are close enough to each other that they can reach each other. So if we take a look at just one laptop, we'll say this one right here is your laptop. Right there. And your wireless adapter can only go so far as the signals it generates. That's because when we generate a signal, it's not going to go around the entire planet 5 or 6 times. It's going to go so many feet or hundreds of feet or thousands of feet or so many miles, depending on the type of antenna and how much power you're putting into it. On a laptop, it's not going to go that far. So this big circle I just put in red, that represents the area where your computer can be reached through its wireless connection. This area is commonly referred to as the basic service set. So I'll put mine in green, so I'll say mine. And so here's my basic service set right here. And let's say the other person, let's use pink for that. And that's their basic service set, or the area within which this device can be reached via its wireless. And if you'll notice, we're all within the area or the basic service set range of each other. And that'd be really important if we wanted all three devices to be able to communicate with each other on this ad hoc network that we put together on the fly. I'd also like you to take a close look at this diagram. What devices do we have in here? Well, we've got a PC, that's yours. We got my PC and the other guy's PC, and that's it. There's no switch, there's no infrastructure devices, there's nothing except our devices. And because we were able to put this network together, this ad hoc network, without any other infrastructure devices, they call it an independent basic service set. And that's what this I is all about. So an IBSS is an independent, not relying on any other infrastructure devices like a switch or a hub or an access point or anything else, just the 3 laptops with their own built-in wireless adapters. So I guess the question is, what would you call it? Would you call it ad hoc or would you call it IBSS? Because you'd be right on either count. We could also call it peer-to-peer. Any one of those 3 terms would be appropriate for this type of topology. Another really common aspect that we're going to see in any of these topologies that we work with is that because it's wireless, we have a half duplex environment. We can either send or receive, but we can't send and receive on the same frequency at the same time. So in effect, our little ad hoc network here is going to operate in half duplex. Although this ad hoc network did perfect for what we needed, which was file sharing, it's not likely in a production corporate environment that we're going to say, okay, we need to share some files. Just, hey, Joe, go ahead and start up an ad hoc network, and Mary, you too. We're going to have some infrastructure in place and control it because we want to specify what networks exist. We also want to control security about who can jump onto those networks. In addition, we might want to provide some access to additional servers and resources, like you might have customers that want to get to the internet. Because the ad hoc network doesn't address those issues, what we're going to see in virtually every implementation of wireless is a little more structure. And to do that, we're going to use something called infrastructure mode. So go ahead and jot down infrastructure mode, INFRASTUCTURE. And write down the whole thing, infrastructure mode. And how do you know if a topology, a wireless topology is using infrastructure mode? The answer is it's got some infrastructure. Specifically, it has an access point. This is like the hub for a wired environment. However, it's the central point for a bunch of wireless clients who want to connect and join onto a wireless network. So AP, or access point, is yet another acronym that we need to be aware of. What exactly is it? Well, if you go into Starbucks or McDonald's, if you look around, you'll very likely see this little device on the wall, and they'll very likely have a blinking light. That is the access point. That's the wireless radio that allows the customers in those establishments to associate with it. And through that access point, that's how they provide access to internet, which is typically done in those establishments. There's lots of different models of access points. There's some that are built for indoors and some that are built for outdoors, and some use this technology and that technology. But the point I want to focus on here is that the access point is the center, or the hub, if you will, for your wireless clients who want to connect to the network. I'd like you to think about the last time that you saw an access point. Maybe it was at a restaurant or a coffee shop or in a business. And I have a question for you. How far away from the access point do you think the client could be and still successfully use that access point in the wireless services? Is it like 10 feet, 100 feet? Is it a mile? How far away can we get? And the answer is, it doesn't go on forever. We'll take a look at the specific technologies in another nugget, but it doesn't go on forever. And the range, the effective coverage range for an access point, is another term that I want you to write down, and that is a BSA. Not Boy Scouts of America, but the basic service area. That's the range for an individual access point as far as the area that it covers, where a client could still successfully use that access point and become part of that wireless network provided by that access point. That is the BSA, the basic service area. Another term that represents the exact same thing that we'll see over and over again is a cell. So we could say that for this access point, this red circle right here represents the basic service area. It also represents the cell, or the coverage that that access point is providing. Now you might be saying, hey, you know what, Keith? This area right here that we just call the basic service area, or BSA, also referred to as a cell, that seems very, very similar to the range based on an ad hoc network of a single device, which we call a basic service set. And so you actually may see that term loosely referred to with an access point as well, regarding the coverage area of a single access point as a basic service set on its own power. However, most of the time, you're going to see this area in red referred to as a BSA or a cell. Now let's say this is your computer right here, and this is mine. and this is the other guys. And let's say we all want to join this wireless network. How do we know which wireless network to join? Because there could be several out there. We're going to be advertising a name, sort of like a group name for the network, and that is called the SSID, the Service Set Identifier. And that'd be another great one to jot down, the acronym as well as the full name of what it is, Service Set Identifier. So if this Service Set Identifier was CBT Nuggets from our computers, when we're looking for wireless networks, we'd find the one that says CBT Nuggets, click on Join, and then follow the bouncing ball. It might ask us for authentication information or other details, which, if required, we would have to provide before the wireless access point would allow us on the network. To point out how really important the Service Set Identifier is, let me give you a wireless tour of my home office here in Las Vegas, Nevada. From where my computer sits, this program right here, by the way, is awesome. It's called INSSIDER as a little play on words. It's called Insider. And what this is showing me is all of the SSIDs that my computer, the one I'm demoing off of, that it can see at this moment. So I have 1, 2, 3, 4, a whole bunch of networks. And some of them are in the 2.4 gigahertz range. I have others that are in the 5 gigahertz range. This is a fantastic tool. But right here, the point I wanted to make is, if we were wondering, you bring up a computer, hey, which wireless network should I join based on the SSID? That would be one great way of selecting the correct network. And then after you select that network, it's very likely that we've got some security in place that we're going to have to get by as well. So from a security perspective, it probably isn't too good to go ahead and use names in your SSID. That because anybody who's driving down the street with an actual antenna, seeing what wireless networks are available, if they were looking for mine, for example, if it's got my name, Barker, it'd be fairly easy to find. Using a fairly generic name like this one or this one or this one, those are actually very good ideas. And that's just because it doesn't make it really super obvious regarding whose wireless network that is. In a production environment, we might have a wireless network for guests, and we might even name that guest network for the benefit of a customer who's visiting. They can select the guest network that's named guest network. It could be very obvious which one they should join, and it could be used for that as well. So I like this one down here, get your own. That's fantastic. And the vendor is just looking at the MAC address associated with that access point. And based on that, this software, Insider, is interpreting what it believes is the vendor of that device. Another great question to ask ourselves is, why would anybody want to associate and join a wireless network? I mean, what's in it for the client? And the answer is, they really probably don't want the actual resources right here on the wireless network. What they're really after is beyond that access point. And that's because the access point, although it is wireless for its clients, it also has this physical connection that goes up to the distribution system. And that's another one that we should jot down the acronym for and also write down the word. Distribution system. That's the connectivity that leads to everything else that these customers might want. For example, they may need access to file servers at the company location. They may need access out through the internet using network address translation and so forth to get there. And this path from the wireless network to everything else is called the DS, or the distribution system. And that's one of the main benefits of joining a wireless network, is to get to the stuff beyond the access point. Oh, you know what? I just thought of a problem. Let's say we have a building that we're doing wireless for. We have a single access point, and that covers, let's say, half of the building. How do we deal with that? I guess we could just wire in everybody on the other half where it doesn't cover, or we could add a second access point, and that second access point could be right here. And between the two of them, they could go ahead and service the entire space where we might need wireless clients. One of the tricky things is that if we have a radio right here blasting out on channel 6 as an example, what would happen if we had access point number 2 also using channel 6? Think of two radio stations that didn't coordinate their efforts with the FCC or anyone else, and they start broadcasting on exactly the same channel. The result of that would be bad news for all the wireless clients, because the radio signals from access point 2 and the radio signals from access point 1 would start bumping into each other. So to assist us with coordinating the efforts between two access points that are going to be working together, we're going to introduce a controller, which is a separate piece of hardware that can manage each of these access points and make sure that they play nice together as they work together to provide wireless service. So as our graphic grows, the next piece that we're adding to this is the second access point, and we're also adding a controller. And this is also known as a WLC, and that guy is right here in our graphic. The wireless LAN controller, or as his friends call him, WLC, or you could also just call him controller. And here's the beautiful thing about using a controller when you have two or more access points. If you have only a single access point all by itself, you might as well configure the access point, do all the dirty work right there, and you're done. However, with two or more, we can make the configuration changes on the wireless LAN controller, and the wireless LAN controller can push those configurations out to the actual access point. So we don't have to visit each access point independently. So for access point 1, here's the basic service area, this blue circle, and we could have channel 6 as a grouping of frequencies we're going to use to send and receive data from access point 1. On our second access point over here, access point 2, with this basic service area represented right here, this pink circle, we could have it use channel 11. Now why? Because we don't want the radio signals from two different access points to start fighting with each other. By keeping them separate, they can both coexist, and this cross section where each of their basic service areas overlap, there won't be a conflict because they're on different frequencies. So I guess the question is, which network are these clients going to join? For example, if that's your computer right here, and this is my computer right here, which network are we going to join? And what we can do is use something called an ESS. It's called an extended service set. It's when we have two or more access points and they are on different frequencies. However, they are all advertising a common network. So you could join the SSID called CBT Nuggets. I could join the SSID called CBT Nuggets. We could both join those wireless networks regardless of which access point we happen to be closer to at that moment. Also, if it's set up correctly, this guy right here, here's the other guy, which access point is he going to associate with? And it's very likely his computer is going to take care of all of that in the background for us. He is going to associate with the access point which he is closest to signal strength wise. And again, that's very likely to be completely transparent to this user. Also, if he roams, if he starts moving around, he takes his laptop, he's walking down the hall, and now he's way over here. Let's say he moves over to this location right here, and he's completely out of the basic service area of access point 1. Because we're using an extended service set and we have the wireless LAN controller in charge of all of it, as he moves to this new area, we can seamlessly put him on this access point. He'll never even know it happened. That's the goal anyway. So he can still be surfing the web or whatever he's doing as he's walking. And if we had 3 or 4 or 5 additional access points and he happened to roam through all of them, the experience for him should just be the fact that he is currently associated with CBT Nuggets. He's on the wireless network, and he also has the benefits of the distribution system, which gives him access to the servers, the internet, or any other resources that we make available through the wireless network. And that ability to move seamlessly, I'm doing seamlessly in quotes, although you can't see me now, you know, that seamless movement between access points is called roaming. And when it works, it's fantastic. If we have a network that's not properly designed or not properly set up, roaming doesn't work by default. So we'll take a look at the steps required to make roaming a reality as we progress in this Nugget series together. So just to clarify, the extended service set is when we have 2 or more access points working in conjunction with a wireless LAN controller, so that for the end user's experience, they see one service set identifier, they can join it and become part of the network. In this video, we've taken a look at how we might arrange and place various devices in a wireless local area network. Now, this arrangement of network devices has another name, and we know and love it as network topology. As we've discussed these topologies together, our vocabulary is increasing. Now, your homework assignment is really simple. I'd like you to take each of these terms that we've discussed in this nugget, and if you haven't already done so, write them out. And then secondly, I'd like you to explain them to someone else. It could be another network professional, it could be a child, it could be a spouse, a loved one, what have you. And the reason is because writing them down is very, very helpful in learning it. But I'll tell you what, when you start communicating this and sharing it with others, your learning is going to skyrocket and your retention is going to increase. I have had a great time. I am so glad you've joined me. I hope this has been informative for you, and I'd like to thank you for viewing.